Hi guys, today we'll be solving CodeTON round 4 problem D, that is climbing the tree. Basically this question says that the snails are climbing a tree. The tree height is h and the h is unknown basically, and the snail starts at position 0. Each snail has two attributes, a and b, a greater than b. Starting from first day, one snail climbs the tree like this. During the daylight hours of the day, he climbs a meters. During the night, the snail rests and slides down b meters. If on the nth day the snail reaches at position h for the first time, he will finish climbing, and we say that the snail spends n days climbing the tree. Note, on the last day of climbing, the snail doesn't necessarily climb up a meters in case his distance is to top is smaller than a. Right. Unfortunately, you don't know exactly the height of the tree, and there are q queries. Query of type 1 will be given a snail, and at first we'll have to adapt our ranges of height given by the tree, whatever the snail says. And event of type 2 asks if it is possible that a snail with attribute this can climb or not. If it can, and it has a obviously a snail can, obviously any snail can, as a greater than b, so anyone will climb. But the question is if it can climb, if we can know the answer precisely, because our h is not fixed. So if we don't know the answer precisely, then it is a problem for us, right? It's another math question. I don't really like math questions as a question D in round in div 1 plus div 2 rounds, and I don't see any point of giving out maths question in a D. But I'm not here to bitch about the problem setting. Let's get back to the uh, solution and understanding of how exactly this works, right? Let's see. Okay, fine. So we have this snails. Okay, snails who go up by a and go down by b at the night. Okay, so let's say at nth day, if the snail reaches okay, at nth day if the snail reaches, then it must have climbed this much. Okay, sorry, it must have climbed this much by the n minus 1th day, and then it climbed a more by the day. So our height is absolutely, like, it is obvious that our height should be less than or equal to this, right? Our height cannot be greater than this. This is the first condition. Our height should also be strictly greater than a minus b into n minus 2 plus a. The reason is that if h is not greater than this, if h is not strictly greater than this, it means that at the end of n minus 1 day only the snail would have finished its journey, right? So there is no point of going another day. So basically our h is a minus b into n minus 1 plus a, and greater than a minus b into n minus 2 plus a. Okay, also if our n is equal to 1, then basically height can range from a to 1, any value, right? Height can range from 1 to a, and as it is strictly greater, we can write it like this plus 1. We can equate it like this. This is because the height is said to be integral, and hence we don't worry about that, and we can write this thing. So basically our height range turns out to be n minus 2 plus a plus 1 is less than or equal to h a minus b into n minus 1 plus a. Okay, now the thing is, we will be given snails. Okay, we will be given snails, and if a certain snail isn't like, if the snails, let's say for query type 1, we are talking, okay, query type 1, let's say if the snail isn't in the range of this, it basically means this either the snail is lying. This is because we are said to adapt the answer according to the according to the order of the snails given, and hence if a snail earlier than this guy, this snail has already said that h should be in this range, it means h should be in this range. Like we have to adapt according to that, and we'll have to reject this if there is no common part in between these two snails. Okay, if these two has a common part, then we'll take the common part. Like we'll take maximum of the left and minimum of the right. Obviously that's logical, right? Because let's say you have a range like this and you have a range like this. What is the intersection of them? Maximum of these two. This was L1 R1, this was L2 R2, and if you have to take common of them, you can see max of L1 and L2 and minimum of R1 and R2 is the common range in between them. And we have to take the common range because the snails should not contradict each other. They should go hand in hand with each other's words, right? So that is why. So this is that. And now we will talk about query type 2. So query type 1 will be this: if the snail doesn't agree with the previous adaptations, then we will print 0, else we will print 1, and we will adapt our h to this by minimizing them. So that is what I have done in my code. Let's read it once. So what happens is, for this we have found the right bound to be this. Okay, fine. The left bound is this and the right bound is this. Okay, so the right bound is a minus b into n plus b. This is the amount which you can by the inlet, that this is the maximum which you can climb, right? This can be written as a minus b into n plus b, right? That is what we have written. Okay, the expression is same. Basically we have here it is b and here that is a. So basically for nth day we can write a minus b into n plus b. So hence you can write that only. Anyways, doesn't matter really. It's pretty much the same expression if you do the math. And for n equal to 1, as I have said, the left bound should be 1 and the right bound should be, when we put n equal to 1 over here, it already comes out to be a, so we don't worry about that. So if n equal to 1, we only change the left bound to 1 because the height can be anywhere between 1 to h, and then we check if they are common or not. If they have a common part, what we do is we take the minimum and the maximum according to what I discussed right over here, and our output is 1, that is we have adapted from this result, and 0 if we have not adapted from this result. Okay, now comes our part of query 2. Okay, so what is query 2 ask? Let's discuss that. Query type 2. Well, let me increase the size of the page a bit. Right. So the query of type 2 says that a and b snail will a snail with attribute a and b will be given. You have to tell how many. Well, can we find answer of it precisely? Can we find the answer precisely? Basically, is there one solution for this? Is there one solution of height? Like we have a given height range, like let's say HL to HR. Okay, max, min, comma max. Let's say I'm saying them right now, min, comma max, mi, comma mx. And if in this range there are multiple solution for a comma b attribute, Snell then we just print -1 for that Snell, and if it doesn't, then we don't basically. Okay, so we know from this expression, if we see, like, if we write it in that expression, a minus b into n plus b plus 1, right? Our minimum should be greater than or equal to this. Our minimum should be greater than or equal to, no, our minimum should be greater than or equal to this, my bad, sorry. This is the n minus 1th, like the n minus what was this, the distance at max which can be traveled by the n minus 1th day, right? And adding +1 to it means that this is the range for the, basically this is the range for, this is basically the height range. Okay, so if we find out the solution for n, okay, if we find out the solution for n in this, it will be by a minus b plus 1 again. Okay, so n we are trying to find out, and and this will give us mn minus b minus 1 plus a minus b by a minus b, right? This is our left, and if mn is less than or equal to a, then we know that in a single day we can travel it. And similarly, if mx is less than or equal to a, we know that. Else we find out the left and right values, that is exactly this, mn minus b plus a minus b minus 1 by a minus b. And similarly for the maximum value we also find, that is basically we are normalizing n and trying to find out if in this range there is a single n present in or not. Basically that is what our main purpose is basically, right? If there is a single n or not. And how we can do it is basically how we can write is basically simple, as a minus b into n minus 1 plus b plus 1 should be less than or equal to mx greater than or equal to mi. Hence we can find out the n in this, and we'll get a left and right. And once we get a left and right from this, we can check if left is equal to right, that is if the solution is same in that range, that is the maximum solution is also equal to the minimum solution which we can get, right? So if it is true, then solution exists and we print out either left or right, because both are same, we don't care. Else we print -1, and that is exactly what I have done. So yeah, this is it. I hope you have understood why this is written like this. If in the nth minus 1 step, let's say if in the nth minus 1 step it reaches in the range of mx to mi, then it certainly means that in the next step it will reach, right? So basically our n will be then as our n, like n will be normalized in between mx and mi in this case. Like, you are getting my point, right? So basically we are using the maximum and minimum like this, because it is the solution range, and the solution range should be reached at max by the n minus 1th step. The solution range, if not reached in the n minus 1th step, then how can we get over the maximum value? And we have to get over the maximum value because our answer can be this mx also, so we have to pass this maximum value, right? So basically that was my logic of solving this question. I hope you liked it. If you like it, please share it with your friends. Okay, I guess this is it for this CodeTON round 4, because I won't be posting A and B, and I haven't even tried E yet. So I guess I didn't participate in the contest, but I was solving because I had some work related tasks, so I didn't participate in the round. Anyways, doesn't really matter. What matters is if you have understood the solution or not. Okay, then let's meet in the next video.